This video is an assembly constraint overview. Assembly constraints allow you to build an assembly prototype by constraining the individual parts together. When constraining the parts are not going to be altered in any way. It typically takes a combination of 3 constraints to fully constrain a part so it is not able to move or rotate. Constraints can be applied to planar faces, edges of parts, circular or linear, vertices, axes, and planes. There are 2 different tools that allow you to constrain parts together. This video will use the standard assembly constraint dialog box instead of the quick constraint dialog box. Some constraints, such as the align and orient constraints, cannot be applied with the quick constraint tool. To open the standard assembly constraint dialog box, click on the standard icon in the constrain group in the assembly tab on the ribbon. In the standard assembly constraint dialog box, you can easily switch between the 2 available options. If the incorrect constraint is chosen, you can select a different constraint and view it by enabling the preview checkbox. Let's take a look at how these constraints work, starting with the mate constraint. You can apply a mate constraint to planar faces on models and reference planes. When you apply a mate constraint, the face normals associated with each face or plane oppose each other, as seen here, and the selected planar entities become coplanar. You can also offset the mate by specifying a distance between the mated entities. You can apply an align constraint to planar faces, reference planes, cylindrical faces, model edges, and axes. When you apply an align constraint to 2 planar faces, the face normals associated with the faces become parallel and point in the same direction. The align constraint is particularly useful for lining up cylindrical items with holes and axes. If 2 cylindrical surfaces are selected, their center axes will be aligned. You can apply an orient constraint to planar faces, edges, or axes. When you apply an orient constraint to 2 planar faces, the face normals associated with the faces become parallel and point in the same direction. The planes, however, do not become coplanar. An orient is basically an align constraint with a variable offset value. When applied to edges or axes, the orient constraint causes the selected edges and/or axes to become parallel. You can apply a tangent constraint to cylindrical, spherical, conical, toric, and planar faces. A tangent constraint creates a tangency between the selected entities. Tangent outside face normals are in opposite directions. Tangent inside face normals are in the same direction. You can apply an angle constraint to planar faces, model edges, and axes. An angle constraint positions one face or edge at an angle to a second face or edge. As an example, the faces of these 2 parts are constrained at a 45-degree angle to each other. This video was an assembly constraint overview. Assembly constraints allow you to build an assembly prototype by constraining the individual parts together. It typically takes a combination of 3 constraints to fully constrain a part so it is not able to move or rotate. Constraints can be applied to planar faces, edges of parts, cylindrical or linear, vertices, axes, and planes.